Start.
Good morning, students. Welcome to Maths 2A class. Today, we are studying some more concepts in theory of equations. In our previous class, we have studied about the definition of nth degree polynomial, monic polynomial, roots of polynomial equations, and the relation between the roots and the coefficients in an equation. Today, we are going to learn about honors or synthetic division method, solving an equation when two or more its roots are connected by certain relations, multiple roots or repeated roots, and solving some problems when roots are in AP or GP or HP. Now let us start our first topic, that is honors or synthetic division method. Synthetic division method. So in this method, it consists of two parts. First one is finding the quotient and the remainder when the nth degree polynomial, that is a0 x power n plus a1 x power n minus 1 plus so on an is divided by a linear polynomial. Okay. The first concept is finding the quotient and remainder when the nth degree polynomial is divided by linear polynomial x minus a. And the second one will be finding the quotient and the remainder when the degree polynomial is divided by the polynomial which is quadratic. See here, x square minus px minus q. Since the highest power of variable is 2, it is called as quadratic polynomial. So one is linear polynomial, another is quadratic polynomial. Now let us check one concepts so that it will be clear to you to understand the topic. So first question, find the quotient and the remainder using synthetic division when the given biquadratic polynomial is divided by x minus a. So here it is a linear polynomial. So my work is to find out quotient and remainder using synthetic division. So in this concept, first of all, we will note down the coefficients of the x variables. Okay. Here the coefficients of the polynomial are noted first. So what is the quotient of x power 4? 1. So write down 1 here, and next highest power x cube, its quotient is minus 6. So I wrote minus 6 here, and next highest power x square, its quotient is 3. Here I wrote 3, and in the same way 26 and minus 24. If any quotient of the degree of x is not present, for example, the polynomial is not having x cube term, then we will write that quotient as 0. So here we have the quotient of every variable, so every term. So I am writing all the quotient first. And in this method, see this factor, linear factor, x minus 4. So by applying minus to this term, taking the second term, that is 4, we will start the division, that is synthetic division. In this method, here we will place 0 first. We will start with 0. Now add these two terms. 1 plus 0, you will get 1. Okay, see here carefully. 1 plus 0, 1. Now 4 into 1, 4 1 ja 4 is written here. Now again add these two terms, that is minus 6 plus 4, which is minus 2. Now multiply this. 4 into minus 2, that is minus 8, is written here. Now again add these two terms, 3 minus 8, that is minus 5. So again multiplying this 4 into minus 5, I will get minus 20. Once again add 26 minus 20. I will get 6. So 4 into 6, 24. So minus 24 plus 24, I will get 0. So in this process, the place here is said to be remainder. So if we get 0 as the remainder, then we can call x minus 4 as a factor and 4 as the root of that polynomial. And how will we get the quotient? Since the biquadratic fourth degree polynomial is divided by linear polynomial, the quotient will be in cubed polynomial. So applying this 1 into x cube minus 2 into x square minus 5 into x plus 6. Thus, the quotient will be x cube minus 2x square minus 5x plus 6 and the remainder is 0. Children, once again remember, if the remainder is 0, then x minus 4 is a factor of this polynomial and 4 becomes the root of that polynomial. Now let us check one more problem. Find the quotient and the remainder using synthetic division when 2x power 5 minus 3x power 4 plus 5x cube minus 3x square plus 7x minus 9 is divided by x square minus x minus 3. Here it is a quadratic polynomial. Okay. So by the method of synthetic division, we have again take the quotients of this polynomial. So x power 5 term is there, x power 4, x power 3, x power 2, x power 1 and x power 0. So we have every term. So we will take the quotients directly. So 2 minus 3, 5 minus 3, 7 and minus 9. So here again see the second and third term here. So this is minus 1 and minus 3. So while taking in the synthetic division method, we will apply minus to these coefficients. So minus 1 will become 1 and minus 3 will become 3. So first of all, we will write 1 and write down again here also we will start the division with 0 only. So 0. Next here I am taking minus 3 as 3. Again I should take 0. The first term will be 0. Now once again add these 3 terms. What you will get? 2. So 2. So 1 into 2, 2. In this row only I am writing the information, that is 1 into 2, 2. And again 3. Since it is in the second place, the 2 terms should be 0. So again second place is 0. Now add these 3 terms, what I will get? 3 minus 3 plus 2, that is minus 1. Okay. Now multiply this 1 into minus 1. I will get minus 1. 3 into 2, previous one. 3 into 2, 6. Once again add these terms. 5 plus 6, 11. 11 minus 1, 10. Okay. So once again 1 into 10, 10. 3 into the previous one, minus 1, minus 3. So again add this one. Minus 6 plus 10, that is 4. So once again 1 into 4, 4. 3 into previous term, that is 10, 30. Add this one, what I will get? 41. So once again 1 into 41, that is 41 here it should be, and 3 into 4, I'll get 12. So here the quotient is not 0. So what I can say about this quadratic polynomial? It is not the factor of this polynomial. Okay. So the quotient and remainder can be written as, see here. Here fifth degree polynomial is divided with second degree polynomial. Then the quotient will be 5 minus 2, that is cubic polynomial. So the answer will be, that is quotient will be 2 into x cube minus 1 into x square plus 10x, 10 into x plus 4. And the quotient is in this form and the remainder is 41x plus 3. Is it clear? Now let us check some more problems related to relations between roots if they have given relations between roots. So solve the equation. So solve the equation if roots have been related, that is one root being twice the other. So see here, let alpha, comma beta, comma gamma. Here the equation is x cube minus 7x square plus 3x is equal to 0. So I should solve this cubic polynomial, and what they have given one root being the twice the other. So since it is a cubic polynomial, I am taking alpha, beta and gamma with the three roots of that polynomial equation. And what they have given that one root is twice the other. So I am considering that one root as beta. So beta is twice, that is 2 times the other alpha. So beta value is equal to 2 alpha. Okay. So from this one, I have the concept that S1 is equal to sum of the roots, that is alpha plus beta plus gamma is equal to minus A1. What is the value of minus A1 here? Minus of minus 7, that is 7. And S2, that is alpha beta plus beta gamma plus gamma alpha is equal to A2. So here it is the quotient of X. Since the equation does not have X term, so the quotient will be equal to 0. So A2 is equal to 0. And S3, the third relation is alpha into beta into gamma, which is equal to minus A3, which is equal to minus 36. So here already I have the value of beta as 2 alpha. So on substituting beta value in the above three equations, what I will get? See here, alpha plus 2 alpha, that is 3 alpha plus gamma is equal to 7. And second equation, in the place of beta, again I am substituting 2 alpha. Okay, so 2 into alpha, 2 alpha square plus 3 alpha gamma is equal to 0 is the second equation. And in the third equation, if I substitute beta is equal to 2 alpha, I will get 2 alpha square gamma is equal to minus 36. Here, my work is to find out the values of alpha, beta, gamma by solving these three equations. So, by solving 1 and 2, I am solving 1 and 2 so that I will get the value of alpha. So, to get the value of alpha, I should remove gamma term. Okay. So, for that, I am multiplying the first equation with 3 alpha and subtracting with second equation. So on eliminating gamma from 1 and 2, we get, that is 3 alpha into 1 minus 2. I will get 9 alpha square plus 3 alpha gamma minus 2 alpha square minus 3 alpha gamma is equal to 21 alpha. Here 3 alpha gamma plus and minus get cancelled. So 9 alpha square minus 2 alpha square, that is 7 alpha square minus 21 alpha equal to 0. So I can take 7 alpha common from this. So 7 alpha into alpha minus 3. So since 7 cannot be equal to 0, then either alpha is equal to 0 or alpha minus 3 equal to 0. That is alpha equal to 3. But you observe that if I substitute alpha equal to 0 in our given cubic equation, it does not satisfy. It does not satisfy means it is not a root, but alpha is a root. So alpha value cannot be equal to 0. Therefore, alpha value should be equal to 3. Since beta is equal to 2 alpha, by substituting alpha value in that, I will get 2 into 3, that is 6. And by substituting the alpha beta in the first equation, that is sum of the roots is equal to 7, I will get gamma value as minus 3. Hence, by solving, I got 3, 6 minus 2 are the roots of the given cubic polynomial equation. Now let us see one more problem. Given that the sum of two roots of x power 4 minus 2x cube plus 4x square plus 6x minus 21 equal to 0 is 0. Find the roots of the equation. See here, what is the power or highest power of the x here? It is 4. So it is a biquadratic equation and it has 4 roots. What they have given that sum of 2 roots of this equation is 0. Okay, for my convenience, I'm taking alpha, comma beta, comma gamma and delta as the 4 roots of this equation. And they have given that sum of 2 roots is equal to 0. I'm taking that roots as alpha and beta. Then I will get alpha plus beta is equal to 0. Now consider S1. That is relation between the coefficients and roots. S1 is equal to sum of the roots is equal to minus of minus 2, that is 2. So see here already I have the value of alpha plus beta is equal to 0. Substituting in this equation I will get gamma plus delta is equal to 2. So we have gamma plus delta is equal to 2 and alpha plus beta is equal to 0. So for my convenience, I am considering alpha into beta, product of the roots is equal to P and product of other roots is equal to Q. Is it clear? Now see here, the equation, the quadratic equation with root alpha and beta can be written as x square minus sum of the roots into x plus product of the roots. Here the roots are alpha and beta, sum of the roots is equal to 0. So I am substituting 0 and product of the roots is P. So this is the equation with roots alpha and beta. Similarly, I can frame another equation with roots gamma and delta. So x square minus sum of the roots into x plus product of the roots. But these 4, that is alpha, beta and gamma, delta, are the roots of the given biquadratic equation. So their multiplication should be equal to this biquadratic equation. So by equating and solving, I will get x square plus p into x square minus 2x plus p. And by simplification, I will get x power 4 minus 2x cube plus p plus q into x square minus 2px plus p cube. So here two equations are equal if and only if their coefficients, corresponding coefficients will be equal. So comparing the coefficients, I will get 4 is equal to p plus q and minus 2p is equal to 6. So from the above equation, I will get here, what is the value of p here? P is equal to 6 by minus 2, that is minus 3. And by substituting this minus 3 in this equation, I will get q is equal to 7. So I got 2 of the roots, okay? That is p and q values. So by substituting that values, I will get the equation. So see here one of the equation is x square minus 3 and another one is x square minus 2x plus 7. So by solving this one, that is x square minus 3, if I equate this one to 0, I will get the roots of this equation. So x square is equal to 3. Therefore, x is equal to plus or minus 3. These are the roots of the first factor. And what are the roots of the second factor? By using formula or factorization method, I will get the roots of this quadratic polynomial as 1 plus or minus I root 6. So these 4 are the roots of the given biquadratic equation. Next topic is multiple roots or repeated roots. So which roots can be called as multiple roots or repeated roots? See here, if a polynomial equation f of x of degree n have m equal roots, okay? It is having m equal roots, which is alpha. That is alpha is occurring m times, where 1 less than m less than or equal to n, then the equation is said to have multiple roots or repeated roots. That is alpha is repeating m times and alpha is a root of the equation with multiplicity m. So it is occurring m times. Okay. So roots of multiplicity 1, that is the root occurring one time, is called simple root. Is it clear? So procedure to find multiple roots. So how we can find multiple roots or repeated roots of a polynomial equation? So let us find it. So if f of x is equal to 0, have two equal roots. Means it is having two roots which are equal and equal to alpha. So alpha is coming two times. Then the expressions f of x and f dash of x. What is f dash of x? That is derivation of f of x. Okay. If f of x and its derivation expression have same root, that is alpha, then alpha is said to be the root of f of x occurring twice. Similarly, if f of x is equal to 0, have three equal roots. Here alpha is occurring three times, repeating three times. Then the expressions f of x, f dash of x, and f double dash of x, that is double derivative of f of x, have alpha as their common root. Now let us check some of the problems to know this concept. So problem 1. Find the multiple roots of 27x cubed minus 36x minus 16 equal to 0. See here, once observe the question. They are not asking you to find all the roots of this cubic expression. So we have three roots, but they are not giving that solve the equation. They are asking us that find the multiple roots. So if the equation is having multiple roots, find that multiple root. Okay. So let us start it. For my convenient, I am considering this equation as f of x. So f of x is equal to cubic polynomial 27x cubed minus 36x minus 16. So I am differentiating f of x here. So f dash of x is equal to. So in your previous classes, that is in your first year, you have read about derivatives. So what is the formula d by dx of x power n? That is differentiating with respect to x. D by dx of x power n is equal to n into x to the power of n minus 1. And what is the value of d by dx of x? It is 1. So let us differentiate the expression here. So what is the differentiation of x cube you get? You get 3x square. So 27 into 3x square, that is 81x square. Next, d by dx of x, that is 1. So minus 36 into 1, minus 36. And differentiation of a constant term with respect to variable will be equal to 0. Since x is not there, the value of d by dx of minus 16 is 0. Is it clear? So what is the value of f dash of x? 81x square minus 36. So taking 9 common, I will get 9x square minus 4. So see here, this 9x square can be written as 3x whole square minus 2 square. So a square minus b square formula. So it can be written as 9 into 3x plus 2 into 3x minus 2. So clearly, if I substitute x is equal to minus 2 by 3 here. See all of you, if I substitute x equal to minus 2 by 3 here, this factor will become 0 and f dash of x will become 0. That means x equal to minus 2 by 3 is the root of f dash of x. Similarly, if I substitute x equal to 2 by 3 here, again it will become 0. So 0 into anything 0. Once again f dash of x is equal to 0. So here I can conclude that minus 2 by 3 and plus 2 by 3 are the two roots of this f dash of x. Now my work is to check whether which one is the common root with f of x. So substitute here. Since we have f of minus 2 by 3. So if I substitute x equal to minus 2 by 3 in this equation, I will be getting 0. And if I substitute 2 by 3 here, I'm not getting 0. So that means f of minus 2 by 3 equal to 0 and f dash of minus 2 by 3 equal to 0. That is minus 2 by 3 is the only common root of f of x and f dash of x. Okay. That means minus 2 by 3 is repeated root of order 2 of f of x equal to 0. Since f of x and f dash of x have same root minus 2 by 3 as common, so it is repeating 2 times. Okay, let us check one more problem. See here, prove that x power 4 x power 5 minus 5x cube plus 5x square minus 1 has 3 equal roots and find this root. So they are saying that this fifth degree equation, polynomial equation, have 3 equal roots. Our work is to find out that root. Okay, that root is occurring 3 times. So again, by differentiating f of x, what I will get? F dash of x is equal to, what is the formula here? D by dx of x power n is equal to n into x to the power of n minus 1. So d by dx of x power 5 will be equal to 5x power 4. Next, d by dx of x cube is 3x square. So minus 5 into 3, that is minus 15x square, plus d by dx of x square, that is 2x, 5 into 2, 10x, and d by dx of minus 1, that is equal to 0. So f dash of x will be equal to 5x power 4 minus 5x square plus 10x. And here they are saying that it is having 3 equal roots. So for that we should also find f double dash, that is double derivative of f of x. So once again, differentiating this equation, I will get f double dash of x is equal to x power 4 derivation will be equal to 4x cube. So 5 into 4, that is 20x cube. Here it is x square. What is the differentiation of x square? 2x. So minus 15 into 2, that is minus 30x, plus d by dx of x is 1. So it is plus 10. So clearly by substituting x equal to 1 in f of x and f dash of x as well as f double dash of x, I am getting f of 1 equal to 0, f dash of 1 equal to 0, and f double dash of 1 is equal to 0. This is a property of root. And I can conclude that x minus 1 is a common factor of these 3 expressions. Is it clear? Since 1 is a root, x minus 1 will become the factor of that expressions. Thus, f of x equal to 0 has 3 equal roots. It has been confirmed that it has 3 equal roots, and that root will be equal to 1. Now we will see the concept that solving the problems when roots are in AP or GP or HP. So what are AP, GP and HP? Do you remember it? In your 10th class of progressions, you have read that AP, that is arithmetic progression, GP is geometrical progressions, and HP is harmonic progression. So when roots of the quadratic equation or cubic equation and so on, nth degree polynomial equations are related in these conditions or in this progression, how we have to do the concept and solve the problem. We will check that concept in this topic. For a cubic polynomial, when the roots are in AP, okay, that is for a cubic equation, that is it has 3 roots. If the roots are in AP, then we consider that roots as a minus d, a and a plus d. See here, these terms are there in AP? T2 minus T1. Do T2 minus T1. What you will get? A minus A plus D. So answer will be D. And again 3T minus T2. T3 minus T2, you will get D. So where D is the common difference. These 3 terms are in AP. So if they will given, if the condition is given that the roots of the cubic equation are in AP, then we should consider that the roots are in this form and then we should solve the problem. Similarly, if they are giving that the roots are in GP, then we will consider the roots as A by R, A and AR, where R is the common ratio. This is the general terms in GP. And next, if the roots are in HP, then they are taken as 1 by A minus D, 1 by A and 1 plus A plus D. So here, if A minus D, A and A plus D are in AP, then we can say that 1 by A minus D, 1 by A and 1 by A plus D will be in HP. So if they have given biquadratic equation, that is 4th degree polynomial equation, and again they are saying that the roots are in AP, then we will consider the roots as A minus 3D, A minus D, A plus D and A plus 3D. Again, D is nothing but common difference. In GP, then what we will take? A by R cube, A by R, AR and AR cube. Children, you can check by concept, that is T2 by T1, T3 by T2, you will get the same value as ratio, okay? Next, if they are given the roots are in HP, we can take them as 1 by reverse of this AP, okay? Let us solve the problem based on this concept. So this is the most important problem which will be occurring, used, asked regularly. So in this concept, you are having 3 terms, that is AP condition, GP condition and HP condition. Now we are going to solve this problem by using these 3 conditions. So first of all, check what has been given. Given that the roots of this equation. So first of all, write that equation, that is x cube plus 3px square plus 3qx plus r equal to 0. So by comparing this cubic polynomial with the standard cubic polynomial, I will get a1, that is x square coefficient as 3p, a2 as 3q and constant a3 is equal to r. So let us check first condition. If they are given that the roots are in AP, I should show the condition as 2p cube minus 3qp plus r is equal to 0. So since the roots are in AP, I can suppose that roots are a minus d, a and a plus d. Okay. So first condition, that is sum of the roots s1 is equal to minus a1. What is s1? Sum of the roots a minus d plus a plus d is equal to minus a1, that is minus 3p. So here d and d get cancelled. I will get 3a is equal to minus 3p. So by solving, I will get a is equal to minus p. So since a is the root of the given cubic polynomial equation, so by the definition of root, it should satisfy the cubic equation. So a cube plus 3pa square plus 3qa plus r equal to 0. But what is the value of a I got in the previous topic? So a is equal to minus p. By substituting that minus p in the place of a in the previous equation, I will get minus p whole cube plus 3p into minus p whole square plus 3q into minus p plus r equal to 0. That is, see here, minus p whole square means it is p square. P square into p cube. So 3p cube minus p cube, it will be 2p cube minus 3p cube plus r is equal to 0. This is the condition they have asked us in the case 1 to show it. So we got the condition. Now we are taking second one, that is if the roots are in GP. Again, what we should consider here, if the roots are in GP for the cubic equation, we will suppose the roots as A by R, A and AR. Here, to not get confused here, I am taking capital R. Is it clear? So again, taking the third condition, that is S3 is equal to minus A3. What is S3? Product of three roots. So substitute these roots here. A by R into A into AR is equal to, what is the value of minus A3? Minus R. So here R and R get cancelled. Capital R and R get cancelled. I will get A into A. That is A cube is equal to minus R. Sending the cube to right side, I will get A is equal to minus R whole to the power of 1 by 3. Again, the concept that A is a root of this cubic equation, it should satisfy the cubic equation. So by substituting it, I will get minus R whole to the power of 1 by 3 whole power 3 plus 3p into, in the place of A square. See here, in the place of A square, I will get minus R whole to the power of 1 by 3 whole square plus 3q into minus R whole to the power of 1 by 3 plus R is equal to 0. So children, see here, 3 and get 3. Here numerator 3 and denominator 3 get cancelled. I will get minus R to the power of 1. That is minus R. Here, R by 3 whole power 2. So it will be 3 here. Since it is square, minus will be disappeared. I will get 3p R to the power of 2 by 3. And here, minus 3q R power 1 by 3 plus R equal to 0. Here minus R and plus R get cancelled. So I am taking here 3 also, sending this minus 3QR power 1 by 3 to the right side and cancelling 3 on both sides. I will get P R to the power of 2 by 3 Q into R to the power of 1 by 3. Now cubing on both sides, what I will get? P cube R square is equal to Q cube R. So R and R get cancelled, that is P cube R is equal to Q cube. Once check your question problem, that is P cube R is equal to Q cube is a condition which they asked us to show. So it has been proved. Now case 3, that is if the roots are in HP. See, children, carefully see this condition. If the roots are in HP, we will put, for my convenient, y is equal to 1 by x. Okay, I am taking y is equal to 1 by x. Then from this condition, I will get x is equal to 1 by y. So substituting x value in the above equation, I will get 1 by y whole cube plus 3p into 1 by y whole square plus 3q into 1 by y plus r equal to 0. That is 1 by y cube plus 3p by y square plus 3q by y plus r equal to 0. So LCM y cube. By taking LCM y cube, I will get ry cube plus 3qy square plus 3py plus 1 equal to 0 are in AP. See here, if the roots of x are in HP, since x is equal to 1 by y, this equation will have the roots in AP. Since these are the reciprocal values, you know that HP is equal to 1 by AP condition. So again, see here, since the equation has the roots in AP, I can suppose or take the roots as A minus D, A and A plus D. Okay. So S1, that is sum of the roots, is equal to minus y square quotient by y cube quotient, that is minus 3q by r. So here D and D get cancelled. 3a is equal to minus 3q by r. So again 3 and 3 get cancelled. I will get a is equal to minus q by r. So since a is the root of the equation, I will get RA cube plus 3QA square plus 3PA plus 1 equal to 0. By substituting the A value, that is minus Q by R, I will get R into minus Q by R whole cube plus 3Q into minus Q by R whole square plus 3P into minus Q by R plus 1 equal to 0. So by separating the powers and by taking LCM, we will get minus Q cube plus 3Q cube minus 3PQR plus R square equal to 0. So solving this 3Q cube minus Q cube, that is 2Q cube is equal to, by sending these two terms to right side and taking R, I will get 2Q cube minus R into 3P cube minus R, which is the required equation or expression which they asked to find out. Okay. So in the three conditions, we got the conditions which they have been asking. Is it clear? Okay, children. Now note down today's homework problems. In the next class, we will see some more topics.